Every time you ask an AI to write a line of code or draft an email, a silent transaction occurs in a data center thousands of miles away. It is not just math. It is physical silicon consuming power, wearing down, and racking up a bill. For 3 years, a single company has controlled the price of that transaction, extracting profit margins unheard of in modern hardware history. But that monopoly is about to break. To understand why your AI subscriptions remain expensive, you have to look at the hardware tax. During the initial gold rush, building artificial intelligence was all about training. Tech giants bought up thousands of top-tier processors, clustering them together to teach neural networks how to understand human language. NVIDIA was the only player ready with both the chips and the proprietary software, called CUDA, to make those chips cooperate. This software lock-in created a digital toll booth. If you wanted to build AI, you paid the NVIDIA tax. Startups burned through billions of dollars in venture capital, not paying for developers or research, but simply paying to rent time on someone else's silicon. But in 2026, the underlying economics of the industry shifted. The era of massive, multi-billion-dollar training runs is giving way to the era of deployment. In the tech industry, this is called inference, actually running the model to answer queries from everyday users. Most people assume that as AI models get smarter, they naturally get cheaper to run. But that is where everyone is wrong. While training is a massive, one-time cost, inference is a perpetual, daily drain. If a company has 10 million users asking questions all day long, the server costs accumulate second by second. In this new world, raw computing power is no longer the metric that matters. The only metric that determines whether an AI company survives is the cost per million tokens. To understand why this is a hardware problem, we have to look at how these processors actually work. In a foundational 2020 paper on AI hardware, researchers Saif Khan and Alexander Mann explained that deep learning requires billions of incredibly simple mathematical calculations to happen simultaneously. General-purpose computer processors, like the CPU in your laptop, are like highly trained academic researchers. They can solve incredibly complex problems, but only one at a time. AI processors, or GPUs, are like an army of elementary school students doing basic addition all at once. But during daily inference, a strange physical bottleneck occurs. The bottleneck is not how fast the chip can calculate. The bottleneck is how fast it can pull the model's weights out of storage and bring them to the processor. Imagine a world-class chef who can cook a meal in 3 seconds, but has to walk down a long hallway to a dark basement every time they need a single ingredient. The chef is idling. This is the memory bandwidth bottleneck, and it is the physical limit of modern AI. This physical bottleneck is exactly where AMD saw its opening. AMD is the classic challenger of Silicon Valley. For decades, they watched Intel dominate the computer processor market, only to quietly build highly efficient, multi-chip architectures that eventually broke Intel's monopoly in both consumer PCs and massive cloud data centers. Now, they are running the exact same playbook against NVIDIA. Instead of trying to build a chip that calculates slightly faster, AMD focused on the kitchen layout. Their recent accelerators, like the MI300 and MI325 series, were engineered with a massive amount of high-bandwidth memory directly on the chip package. By packing more memory onto a single piece of silicon, AMD solved a critical math problem for cloud providers. It meant they could run incredibly large models on fewer physical chips, cutting down on both power and hardware costs. But building a great chip was only half the battle. For years, NVIDIA's real moat was not its hardware. It was CUDA, the proprietary software platform that developers use to write AI programs. For a decade, if you wrote code for an AI model, it was written specifically to run on NVIDIA silicon. Trying to run that code on an AMD chip was like trying to play a PlayStation game on an Xbox. It simply would not work without rewriting millions of lines of code. But AMD did not try to build their own proprietary wall. Instead, they backed an open-source rebellion. By supporting open software frameworks like PyTorch and OpenAI's Triton, alongside their own software translation layer called ROCm, they helped build a world where the underlying hardware is completely decoupled from the software. Today, a developer can swap the underlying hardware from NVIDIA to AMD with a few lines of code. The software wall has crumbled. This brings us to the brutal reality of the 2026 price war. Cloud providers are no longer buying hardware based on brand loyalty. They are buying based on cold, hard spreadsheets. By offering chips with massive memory capacity at a significant discount compared to NVIDIA's premium prices, AMD has triggered a massive pricing shift. Cloud providers are using AMD's hardware to run their high-volume, daily inference tasks at a fraction of the cost. More importantly, the mere existence of a viable alternative has forced NVIDIA to do something it has not done in years: negotiate. To keep their dominant market share, the industry leader has had to lower its margins, offering discounts to major cloud partners. The result is a race to the bottom that benefits every single software developer and consumer. The significance of this hardware war goes far beyond corporate profit margins. When a single company controls the infrastructure of artificial intelligence, they control the gate to the digital future. They decide who can afford to build, who can afford to run, and who gets access to the most powerful tools of our generation. By breaking the software lock-in and offering high-performance inference at a massive discount, the hardware market is opening up. The cost of running intelligence is falling towards zero. And as the barriers to entry crumble, the technology moves out of the hands of a few trillion-dollar giants and into the hands of ordinary developers worldwide. The Silicon War is over, and the era of affordable, ubiquitous computing has begun.